All
This
right,
meeting is being recorded.
everyone's gonna get that. All right, hello class. Hope you guys are having a nice day. My name is Mr. Aguilar. Let's go ahead and start with it. Can I have Daniel go ahead and read the standard for me?
Standard P standard 8.G.B.7. Apply the Pythagorean theorem to determine unknown side lengths in right triangles in real world and mathematical problems in 2 and 3 dimensions.
Thank you, Daniel. Steven, go ahead and read the first dot for me for the lesson goals.
Absolutely. And for the lesson objectives, objective number 1 will be by the end of this lesson, students will be able to state and label the sides of a right triangle. Objective number 2 will be students will be able to identify a right triangle and to find the missing side.
All right, thank you. We're gonna skip the do now, and we're gonna go ahead and go with our vocab today. So our first vocab, let's go number 1. Daniel, go ahead and read it out loud.
Number 1, right triangle. A triangle in which one of the interior angles is 90 degrees is called a right triangle.
Steven?
And for number 2, we'll do hypotenuse, the longest side of a right triangle.
Daniel again, leg.
And leg, 2 sides that form the right angle.
Thank you. Now let's go ahead. Let's go 4, 5, 6. These will be our last 3 vocabs. Go ahead, Steven. Number 4.
For number 4, we'll be starting with squared number, which is the result when a number has been multiplied by itself.
Go ahead, Daniel.
Square root, a value that when multiplied by itself gives the number.
Great. Go ahead, Steven, for side.
And for the last one will be side, which is a line segment that joins 2 vertices to form the outline of a 2D or 3D shape.
Great. Now we're going to talk a little bit of Pythagorean theorem. About 2,005 years ago, a Greek mathematician named Pythagoras discovered a special relationship between the sides of right triangles. This has to do a lot with the pyramids. A lot of Greek mythology and Greek mathematicians were so interested in the pyramids of Egypt, so they really want to know how big they are and how they were created. So he came up with the Pythagorean theorem. He realized that if you have a right triangle and you square the lengths of the 2 sides that make up the right angle and add them together, and you get the same number you would get by squaring the other side. So technically speaking, Pythagorean theorem. Let's go ahead. Daniel, can you please read us the Pythagorean theorem?
Pythagorean theorem is stated as follows. The square of the hypotenuse of a right triangle is equal to the sum of the squares on the other 2 sides.
Steven, tell us what's our equation.
So in other words, that can be noted with exponents as a squared plus b squared equals c squared, which is where a and b represent the legs of the right triangle and c represents the hypotenuse of the right triangle.
Right. Do you guys notice anything about the hypotenuse other than it being the longest side? What do you guys notice?
I notice it's adjacent to the right angle.
Right. It's adjacent to the right angle, so it's straight across. So if you don't know which one's your hypotenuse, you gotta know that right here is straight across from the right triangle. And that's how you guys be able to label them. So let's go ahead and start our strategy with labeling first. So first thing we're gonna do is we're gonna do a turn and talk with your shoulder partner about the question, is the red line a leg or hypotenuse? You have 50 seconds to talk to them. Do not talk about irrelevant events. So here we go. The red line, is it a leg or hypotenuse? You have 50 seconds, go.
Well, just going based off what you said, Stephen, it being across from the right angle, I'm going to say it's the red line's the hypotenuse.
Right, perfect. Yeah, agreed. I think another way we can look at that too is we could do a squared, which would be 3 squared to 9, 4 squared to 16. Add those two to 25, which is the same as 5 squared, 5 times 5, which is also 25. So that gives us another route to prove the theory.
Correct. So that should be hypotenuse. The other part, here we go. Another 15 seconds. Here's another right triangle. Is the red line a leg or hypotenuse? Go.
Ooh. I'm going to guess it's a leg. I don't know.
I'm going to go with Daniel as well, and it being a leg, just because, again, it is not adjacent to the right angle. And also, it would obviously be the largest number if it's equaling the sum of the other 2 numbers. So that's usually a good indicator as well.
Great. Leg. Let's do another one. Here we go, leg or hypotenuse, what is it, guys?
I think we're both in agreement that hypotenuse, just based on the same rules applied that we've been using. Again, adjacent to the right angle, and again, will match 6 squared plus 8 squared will equal 10 squared.
Right,
Agreed.
hypotenuse. So now let's go ahead for our first example. I will do it with you guys. So it's an I do, we're gonna solve the variable D. Here it comes. And let's go ahead and set it up. The first thing I noticed is that if you guys take a look, I'm gonna label mine. So I have my A being 6, my B being D, and my C being 10. Why do I know that's the C? Because it's across from the hypotenuse from the right triangle. It's our hypotenuse because it's the longest side. So as I continue to set this up, you guys will be able to see that I continue to solve it. 10 to the power 2, 100, 6 to the power 2, 36. Then I have to subtract 36 from both sides. And then you guys will be able to see that after I'm done with this, you'll be able to see it being solved, D squared. And then I have to do square root. And then I get D equals 8. Now we're gonna do a we do where you guys are gonna follow, we're gonna do it all together. So get yourselves ready. Here's the we do. What's the first step I'm gonna do? Here's our triangle. What's the first step?
All right, I think the first step is going to be to identify what A is and what C is. We already know that C is the hypotenuse. We've already determined that that's going to be adjacent to the right angle. So it will be safe to assume that 26 will be C. And then just through deductive reasoning alone, it'll let us know that 10 is the A.
Good job. Now, Stephen, if I go ahead, I'm gonna set this out. You did great. Daniel, so if I set this up, right? So it's gonna be like that, right? 10 to the
Mhm.
power 2 plus B squared 26. What do you think is gonna be my next step?
Your next step, then we have to multiply it by its exponents.
Okay, so what'll be 10 to the power 2?
Was that 100?
100.
Correct. 100
My
and
calculator for 26.
Yeah,
use the calculator, guys. You may use the calculator for 26 to the
I'm
power.
good at this. That's
So
like
we got
400.
6, and then we'll solve for the hypotenuse as well. So just so we can plug this in. So 26 to the second power, or 26 squared, would be 676.
Right. Here we go. Now, after that, how can I leave B squared by itself?
We're gonna have to subtract 100 from both sides.
Correct. And what will you get?
What was that? 576?
Correct. So you're left with 576. So after I have B squared to 576, how can I get rid of the square?
Perfect. We'll do the square root, which is opposite operation.
Reciprocal. You can say that, and there you go. B equals 24. Now I'll give you guys a few minutes to do the I do. The I do is for you guys to do. So go ahead. I want Daniel to go ahead and read the word problem.
All right, solve the missing side. Jerry put the ladder up against the wall. The ladder is 13 meters and the wall is 12 meters. How far is the bottom of the ladder to the wall?
Which is the ground. So go ahead, guys. Try to figure it out on your own.
All right, so what? We got A, B, equals C. 144 plus.
We got 10 minutes left. Let's get this done.
Is it 5?
Correct. There you go. Awesome job. Okay, so I'm gonna stop recording right now.